Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Kenneth Laskin. As usual, we first come to its statement. Copper has a density of 8.96 gram per centimeter cubic centimeter, and molar mass of 63.5 gram. Calculate the center to center distance between copper atoms in the face centered crystal structure. Face centered crystal structure. Copper has a density of 8.96 gram per cubic centimeter and molar mass of 63.5 gram. Calculate the center to center distance. Center to center distance between copper atoms in the FCC face centered crystal structure. As usual, we first come to its after going through statement, we now come to helping tools. Okay, this is the first helping tool, and this tool has been explained in several versions. Okay, this is the first version of this helping tool, the face centered cubic structure. Okay, the face centered cubic structure, FCC structure. Okay, next other version of this helping tool. Okay, the face centered cubic structure of sodium chloride. The coordination number, the number of nearest neighbors about each ion, is 6. Next version, face centered cubic, FCC. Okay, if we consider this, there are 1, 2, 3, 4, 5. This is complicated. 6 atoms. The face centered cubic structure of sodium chloride, the coordination number, the number of nearest neighbors about each ion is 6. 6. Next version, sodium chloride. How many atoms? 1, 2, 3, 4. Next version, face centered cubic. Okay, now in helping tool number 2, Avogadro's number has been defined because Avogadro's number is used in solving this problem. Okay, so Avogadro's number has been enumerated as a helping tool. Okay, 1 mole of a substance contains Na Avogadro's number elementary units, usually atoms or molecules, where Na is found experimentally to be Na equal to 6.02 into 10 to power 23 per mole Avogadro's number. 1 molar mass M of any substance is the mass of 1 mole of the substance. Helping tool number 3, a mole is related to the mass M of individual molecules of the substance by capital M equal to small into Avogadro's number Na. Helping tool number 4, the number of moles N contained in a sample of mass N SAM, that is N sample, where sample is written just in 3 alphabets. SAM, M SAM consisting of N molecules is related to the molar mass capital M of the molecules and to Avogadro's number Na as given by small n equal to capital N over capital N capital A. Avogadro's number equal to M SAM sample over capital M molar mass equal to M SAM over small m into Avogadro's number. Now we come to its solution. We know that density of copper atoms is N is equal to rho into Avogadro's number over molar mass. Okay, we just put all the values. 2 values have been provided in the statement and 1 has been given in helping tool. So just simplification as in previous problem. Okay, so yeah, however here gram per mole will be cancelled with gram per mole. Moreover, centimeter cube will be converted into meter, so it will be written as 1 over 100 meter cube, and hence after simplification density of copper atoms N will become equal to 8.494 into 10 raised to the power 28 atoms per meter cube. 8.494 into 10 to power 28 atoms per meter cube. Here, students, we have converted this 10 to power 23 into 10 to power 22, and hence in this way we will have to change this 0.8494 into 8.494. okay, that is to say 10 raised to the power 1 will be adjusted in this way. Okay, in the face centered crystal structure, each basic cell has 4 atoms, and hence the length small a of one edge is given as 4 atoms over a raised to the power 3 equal to 8.494 into 10 to power 28 atoms per meter cube. Just same process as in the previous problem. Okay, in previous there were 2 atoms, here are 4 atoms. Moreover, this value was different. From here a cube will be shifted to another side of this, and this factor will be shifted to denominator. Okay, and moreover atoms will be cancelled with atoms, and hence a cube will become equal to this. Here, dear students, because 10 raised to the power 28, we will have to convert it into 10 raised to the power 30 minus 30, because we have to take cube root of this value. So 1/3 of 10 raised to the power minus 30 will be simpler instead of 10 raised to the power minus 28. So when we will change this 10 raised to the power minus 28 into 10 raised to the power minus 30, then we will have to change this figure from 0.471 to 47.1. okay, hence a will become we will take cube root on both sides, and hence meter cube will become simply meter. Moreover, 10 raised to the power minus 30 will become 10 raised to the power minus 10. Moreover, its cube will become 3.61. Okay. Next step is that we change this 10 raised to the power minus 10 into 10 raised to the power minus 9, because we know that 10 raised to the power minus 9 is nano, and nano is denoted by small m. So if we convert this 10 raised to the power minus 10 into 10 raised to the power minus 9, then we will be succeeded in changing this expression in a reasonable form. Okay, so here a will become equal to 0.361 nanometer. Okay, here length of body diagonal is a into 2 under root. In previous problem, this situation was a into 3 under root, but here length of body diagonal is a into 2 under root. Hence this indicates that atomic spacing is half of that. In previous problem, it was half into a into 3 under root. This is half into a into 2 under root. Okay, here just we will put the value of a, and our solution will become 0.255 nanometer. Okay, atomic spacing will become 0.255 nanometer. Atomic spacing has become equal to 0.255 nanometer. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.